All right, guys, second lesson on trig today, trigonometry of right triangles. A lot of things we're going to do with trig all the way through are based on right triangle trig. So really dig in today, make sure you get this, and again, take some notes, and we'll get going here. All right, trig ratios. You should have seen these before, either in algebra 2 or geometry, especially the big three. There's a triangle down at the bottom right there. Make sure I know you know this already, but this angle, we're going to use the word theta a lot. Angle theta, just theta stands for an angle. When you see that Greek letter theta, it's going to represent an angle measure. Right triangle, you have two legs and hypotenuse. Hypotenuse is the longest side. It's the side opposite the right angle. The opposite side is opposite the theta. The adjacent side, adjacent means next door to theta. That is not the hypotenuse. Okay, so you've heard this. I'm sure you've heard this before, but one of the best ways to remember what's up here, these trig ratios, is a word called SOHCAHTOA. SOHCAHTOA, where it stands for S's sine is opposite over hypotenuse, which is right there. Cosine is adjacent over hypotenuse, which is right there. Tangent is opposite over adjacent, which is right there. Now, these next three may be new to you, but they're just reciprocals. Cosecant is a reciprocal of sine, so it's hypotenuse over opposite side, leg. Secant is reciprocal of cosine, and cotangent is reciprocal of tangent. Okay, so they're just reciprocals. So these are the big three, and the other three trig functions are just reciprocals of the first three. All right, what they're going to have you do first is they're going to give you a triangle or two and just say, find the six ratios of the angle theta. They're going to show where theta is. In this small triangle right here, you can see theta is right here. So if I do sine theta, remember sine is opposite, which is 3, over hypotenuse, which is 5. Cosine is adjacent, which is 4, over hypotenuse, which is 5. Tangent is opposite over adjacent, which is 3/4. And then the other ones, cosecant is just reciprocal of sine. Secant is reciprocal of cosine, and cotangent is reciprocal of tangent. Now, I put this other big triangle here to show you one thing. It doesn't matter how big the triangles are, the ratios are still the same. The functions are still the same. If I did sine of that big triangle right there, this big one, I would still go opposite over hypotenuse. I would get sine theta is 30 over 50, which also reduces down to 3/5, which is the exact same thing I got over here. So the size of the triangle is not as important as what the ratios are. Okay, this one says if cosine is 3/4, sketch a right triangle with the acute angle x and find the other 5 functions of x. Okay, so if cosine is 3/4, you're telling me there's angle x. I try to do theta, but my iPad doesn't have it. Sorry. So it says it's 3/4. Remember, cosine is adjacent over hypotenuse. So I'm going adjacent over hypotenuse. I cannot find the other 5 trig functions unless I know what this missing side is. So I'm going to do Pythagorean theorem. A squared, which is 3 squared, plus b squared, which I don't know, equals c squared, which is 4 squared. 4 squared is 16. 16 minus, if I move this 9 over there, it would be 16 minus 9 is 7, which means b would be square root of 7. So this side right here is square root of 7. Now I can find all of them. All right, so sine theta is opposite over hypotenuse. Tangent theta is opposite over adjacent. Now I'm going to do the reciprocals. This one gets a little crazy. Cosecant's reciprocal of sine, so it would be this, except I would rationalize. I can't leave a radical on the bottom, so I get 4 on 7 over 7. I'll teach you a good trick for that tomorrow. Cotangent theta, same deal. It would be 3 over square root of 7, which is really 3 on 7 over 7. I'll teach you a trick for that tomorrow. And, of course, I'm missing one. I'm missing the reciprocal of cosine, which is secant. And secant is just reciprocal of cosine, so it'd just be 4/3. All right, so no big deal. Special triangles. Man, I hope you remember these. Special triangles from geometry, there are 2 special ones in particular. One is the 45-45-90, where the hypotenuse is square root of 2 times bigger than the legs. No matter how big the legs are, the hypotenuse is square root of 2 times bigger. So if we start doing, opposite over adjacent or opposite over hypotenuse, the values are always going to be the same when you have 45-45s. Same thing is true with 30-60-90s, which you also did in geometry. All right, 30-60-90s, everything is based on the short leg. The short leg is opposite the 30. Short leg is opposite the 30. Okay, if it's 1, the hypotenuse is twice as big as the short leg, and the long leg is square root of 3 times bigger. Those should look familiar to you from geometry. We're going to do a whole lot of stuff based on 45-45 and 30-60-90. So much so that this chart that I just put on the slide, you need to know most of this chart. And what I'm going to tell you is you're going to need to know most of, especially these first three right here. Because again, these three over here are just reciprocals of these. Okay, so if I can get these 9 values in your head, then you're going to be so much better off. But you got to learn them. Like, you have to. You need to know which degrees and radians go together. And we did that in yesterday's lesson. We figured out how to do that. Sine and cosine. Look right here. Look what these sine and cosines are, and look what these sine and cosines are. They just switch, right? So no big deal. 45 degrees. Look at the numbers. Square root of 2 over 2 and 1. Are you kidding me? And if you look at the numbers with these, the 30s and the 60s, those come straight from the 30, 60, 90 triangles. That's exactly where they come from. And I'll show you more about that in class. But just know up front, these values that I'm kind of going over again, you need to get those 9 values in your head. And I'm going to give you a couple of ways tomorrow. I hope I can get the way to where that you like, where you can just remember them, because you really need to basically memorize those. All right. The main part of tomorrow is going to be solving for x or solving a triangle. So what they're going to do is they're going to give you an angle, and they're going to give you an x, and have you just find out what that x is. All right. So that x right there is opposite of my angle. And the 13 down here, that 13, because it's opposite the right angle, that's hypotenuse. Okay, I have opposite, looking at opposite, and hypotenuse. So that's sine. So I'm going to do sine 60 degrees equals opposite over hypotenuse. Now, when I work this out, I'm going to use my calculator. And you need to go ahead and look at your calculator. Notice it's 60 degrees. You need to hit your mode button. Make sure you're in degree mode, which I'm doing right now, and I am. And then I'm just going to cross multiply. To get this x, I'm just going to cross multiply here. I'm going to do 13 times sine 60. Just hit exactly what I said. I hit sine 61. That's not good. Sine 60. And I'm getting 11.3. Okay, I rounded that obviously, but there you go. That's all you got to do. You got to figure out which one am I using. Tangent, cosine, or sine. Which one of the big 3 am I using? All right, last slide. This one says solve the triangle. Now, what this means is you got to find everything that's missing, okay, which is a little more difficult than the first one. So first thing I'm missing is the angle that's up here. Now, the good thing about trying to find an angle is I know all 3 angles have to add up to be 180. So I'll do 180 minus 75 minus 9, the 90 degree angle also, end up with 15 degrees up here. So that angle up there is 15. So there's part of the triangle. I also need to figure out what the hypotenuse is. So to do that, I'm going to use the 75 and that 100. That 100 is opposite the 75, and the question mark I wrote there is actually the hypotenuse. So if I'm doing an opposite hypotenuse, that's sine again. So I'm going to do sine 75 is opposite over hypotenuse. I do not know what the hypotenuse is. I'm trying to find that out. Now to solve this one, because the x is in my denominator, I guess I shouldn't have written that yet. There's a shortcut, and I'll get you there tomorrow. But what I'm going to do is I'm going to get rid of the fraction. So multiply both sides by x, like this. All right. And then to get the x, I'm going to divide both sides by sine 75. And that tomorrow I'm going to show you. We're just going to go straight to that step. Okay, so I'm just going to take my calculator, 100 divided by sine 75, and I get 103.5. That's the hypotenuse, 103.5. So that side right up there, 103.5. And the other thing I'm missing is I'm missing this little side right here. Okay, and again, I'm going to use the same thing. This side is opposite to 75. The A I just wrote is adjacent. So I'm thinking, okay, what's opposite and adjacent? SOHCAHTOA, tangent. Tangent is opposite over adjacent. So I'm going to do tangent 75 is opposite over adjacent. And again, the A is on the bottom. All right, so I'm going to end up with this right here. Once I move everything over, I'm going to end up with 100 over tangent 75. And I'm just going to solve that. So I'm going to say 100 divided by tangent 75. And I would get 26.8. And so there's everything. There's this little side over here. We got the hypotenuse, and we got the angle. So we solved the whole triangle, which is what they wanted me to do. Because solving the triangle means just that. Find everything you can. All right. That's quite a bit of stuff. Hope a lot of it you should have seen before. This is SOHCAHTOA. You've done SOHCAHTOA. Okay, so hope it's familiar to you. We'll work on it tomorrow. Give you a couple shortcuts maybe, and we'll see you then.